Day 6 Card Gallery, and the historians use their fancy device again. This time to skew all the way to the North Pole prototype suit manufacturing lab in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. Still have to be careful of time paradoxes, so it will be important to avoid any one from 1518 while the historians search for chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. Start by making a map, your input of the situation. For example, the map shows the current position of the guard with this to indicate the guard is currently facing up from the perspective of a map. Any obstructions are shown as hash. Lab guards in 1518 follow a very strict protocol for patrolling, which involves if there is something directly in front of you, you turn 90 degrees right, otherwise take a step forward. Following the above protocol, the guard moves up several times until she reaches an obstacle, a pile of failed suit prototype. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. Reaching another obstacle, continue the process. By predicting the guard's route, you can determine which specific positions in the lab will be in the protocol path, including the guard starting position. The position visited by guard before leaving the area are marked with X. The guard will visit 41 district in this example. Predict the path of guard. How many distinct positions will the guard visit before leaving the mapped area? So we have to find out all the distinct positions the guard will visit before she actually leaves the map area, and only two possible movements are up, take a step forward, or turn 90 degrees if there is something directly, which means if there is an obstacle. That is for part 1. I have solved both the parts. I'll share in the code solution in Java, the GitHub link. The same part 2. Borrow the fancy devices, step outside the lab from the safety of a supply closet. Time travel through the last few months and record the nightly status of the lab's guard post on walls of the closet. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They would like to place new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. Students would like to know all the possible positions for such an obstruction. The new obstruction can be placed at the guard's starting position. The guard is there right now and would notice. In this example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations, we use 0 to mark the new obstruction. This pipe to show position where guard moves up, down, dash to show position where guard moves left, right, and plus to both up, down, and left, right. These are all the examples. It doesn't really matter what you can choose to use as an obstacle, so as long as you and the historians can put it into position without the guard noticing. Important thing is having enough options that you can find one that minimizes time paradoxes. How many different we need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Let's go to my code solution. What I'm doing to solve is for distinct positions that for the part 1 that the guard visits. We have the map in place, have a start position. Find start is just a method to find out which position the guard is in. Once we have the starting position, we can iterate the up, right, down or left direction depending on where the guard is facing right now, in which direction. We'll keep on checking the next x and y coordinates. If it's outside our grid, then she has left the map. We can come out of our loop. If not, if she comes across an obstruction, then we turn right. Turning right, it's basically having changed the direction 90 degrees to where it currently is. I'm using the start indexes from these. So now that comes out as the first position. Get the modulus for 4 different directions. And otherwise we just move forward. And our visited set includes a distinct entry for this visited position. So for part 1, our answer will be the size of our visited hash set, since that is the unique set of position that the guard goes to. For part 2, what I am doing here is starting with the guard starting position. I'm updating the starting row, starting column. And for each obstruction, I go to a scene and scene recorded hash sets. So for every, I have considered it as a state, because changing directions and having the updated row and column for the new position in the coordinates. For every obstruction, I am adding it to my C. I'm updating the scene RC size to P1. And if the original rows and column are equal to the current one, you'll have to turn right. That updates our rows and column set. every time we come across the same state, that means the same coordinate for row and column, we add it to the scene state, and every time the scene state contains this state, we increment our result count. That means this is the state that we can add to have a loop created for the guard. And finally, P2 will be our number of states that we can add the obstruction at, so that a loop will be created at that point. And that is our answer. This is fairly straightforward, iterating through all the coordinates and updating the scene hash sets. So yeah, I'll be waiting for improved or more efficient solutions from you all. Let me know in the comments. Thank you.